Hi, this is Andrea Hendricks. Let's take a look at the topic of solving rational equations and inequalities. The objectives of this video are to show you how to solve rational equations analytically and also to solve rational inequalities analytically. For the first objective, to solve rational equations analytically, what we're going to do is create a new equation without any fractions. So we will multiply both sides of the equation by the least common denominator to remove the fractions, solve the resulting equation, and then discard any solutions that are restrictions on the variable. And by restrictions I mean values that make the denominator equal to 0. That is where the rational expression is undefined. I'm just going to do two examples here. I've done a lot of examples for the homework video, the My Math Lab homework, and the graphing calculator, so I think you'll get plenty of examples when all of this is said and done. So for the first example, we have 1 over x plus 4 is equal to 2. You can multiply by the LCD of x plus 4, or if you recall, when you have two fractions that equal to each other, you can cross multiply if you like, so that would give us 2 times x plus 4, or 2 times x plus 8 is equal to 1. So subtracting 8 would give us 2x is equal to negative 7. Dividing by 2 is negative 7 halves. So that would be the solution to that equation. For 5 over x minus 2 equals 4 over x plus 3, again we have two fractions equal, so we can cross multiply, or if you want to think about it as multiplying both sides by the product, x minus 2 times x plus 3, since that is the LCD. But in any case, we would get 5x plus 15 is equal to 4x minus 8. So we can subtract the 4x to get x. Subtract 15 from negative 8 gives us negative 23. So that is the solution to that equation. Let me write that again. I'm sorry about that. Now, to solve a rational inequality analytically, we've solved rational inequalities before. Do you remember that? Where we would solve the equation, find the values that make that associated equation true, right? So that's step 1. Then find the values that make the rational expression undefined. This is an important difference in this type of problem, okay? When you're dealing with rational inequalities, you have to think about where is the expression undefined. So we find the solutions of the equation, also find out where it's undefined. We place the solutions and the restrictions, that is the values that are undefined, on the number line, test a point from each region, and then shade the regions attested true, and then we have to determine what symbols, that is, do we use parentheses or brackets on the endpoints. Very, very important note, you always use the parentheses on the restrictions. So whatever values you find in step 2, it doesn't matter if the symbol is less than or equal to or greater than or equal to, you're going to use the parentheses on the values that the function is undefined. So let's look at an example here. 1 over x plus 4 is less than or equal to 2. So step 1 would say we have to first solve the associated equation, which we just did that, do you remember? And we found our solution to be negative 7 halves. Okay, so this is the solution of the equation. But the next thing we have to do is find out where the function is undefined. And it's undefined at the value that makes the denominator equal to 0. So where x plus 4 is equal to 0, or rather where x is equal to negative 4. So on the number line I would have to place negative 4 and negative 7 halves. Okay. And then I'd have to test a number out of A, B, and C. So what is the number out of region A? Yeah, like negative 5. So to have 1 over negative 5 plus 4, is that less than or equal to 2? And that would be 1 over negative 1, which is negative 1, which is less than or equal to 2. So that is true. Now, a number out of region B is going to be very tricky, right? Negative 7/5 is, or negative 7/2 is really negative 3.5. So between negative 3.5 and negative 4 is like negative 3.7, right? So we would have 1 over negative 3.7 plus 4. Is that less than or equal to 2? Well, what is that? That's really 1 over 0.3, right? Is that less than or equal to 2? But 1 over 0.3 is really 1 over 3/10. You could use your calculator to do this. I'm doing this all by hand. But 1 divided by 3/10 is really the same thing as 1 times 10/3, which is just 10/3. But 10/3 is 3 1/3, so that is not less than or equal to 2. And then a number out of region C, like 0. So we'd have 1 over 0 plus 4. Is that less than or equal to 2? Right, that's 1/4, which is certainly smaller than 2. So we can shade which regions, region A and region C. Now, this is where you have to be careful. Less than or equal to means I can include the solutions, right? So that means we can include the solution of negative 7/2. But I can never include where it's undefined, so I always have to put a parenthesis on that. So the final solution to this problem is negative infinity to negative 4 union bracket at negative 7/2 to infinity. Okay. Now, this other example that I have listed, I might need to go to the other page to show you, but in fact, let me do that just so I don't get too cluttered. What is that? 5 over x minus 2 greater than 4 over x plus 3. Okay, so the first thing I do is find the solutions of 5 over x minus 2 is equal to 4 over x plus 3. And again, I worked that example up here to find negative 23. Now, where is it undefined? That would be where the denominators are equal to 0. So we have where x is equal to 2 and x is equal to negative 3. So on our number line, we're going to place these three values. We're going to place negative 23, negative 3, and 2. We have 4 regions to test. Okay. So out of region A, we need to plug in something to the left of negative 23, so maybe we say negative 24. So we would have as 5 over negative 24 minus 2 greater than 4 over negative 24 plus 3. So that's what, 5 over negative 26. Is that greater than 4 over negative 21? And I might have to use my calculator to help me with this. What is that? 5 divided by 26, 0.1923. And then we want to figure out, is that greater than, what is 4 divided by negative 21? Is negative 0.1904. But that would be false, right? Because as we go left on the number line, the numbers get smaller and smaller and smaller, and this number lies to the left of this. Okay? So that was an ugly one. Let's see what happens out of region B. Plugging in a number between negative 23 and negative 3, so let's say maybe negative 4. So is 5 over negative 4 minus 2 greater than 4 over negative 4 plus 3. Oops. So what is that? 5 over negative 6. Is that greater than 4 over negative 1? So negative 5, 6 is greater than negative 4. And that's actually true, right? Because on the number line, negative 5, 6 is to the right of negative 4, so that would be true. Now, a number out of region C between negative 3 and 2, you guessed it, my number is 0, right? So we would have, is 5 over 0 minus 2 greater than 4 over 0 plus 3? So what is that? Negative 5 halves. Is that greater than 4/3? No, a negative can't be greater than a positive. And then our last region out of region D, what do we need? Something to the right of 2, so maybe we choose 3. So we have is 5 over 3 minus 2 greater than 4 over 3 plus 3. So what is that? 5 over 1, which is 5, is greater than 4 over 6. Yeah, and that is true. So the regions that contain solutions are B and D. And what about our endpoints? Okay, in this case we're strictly greater than, which means we cannot even include, we have to exclude the solutions, right? So we're excluding the solutions as well as where it's undefined, so all the symbols are going to have parentheses in this case. So our interval would be from negative 23 to negative 3, union 2 to infinity. Okay? So if you have any questions on how to solve equations and inequalities, watch the homework videos, the MyMathLab homework video, and the graphing calculator. And if that doesn't help, please feel free to contact me. You can do that at any time. Thanks.